What if your server fails? Here, you can see a standard application setup. Your data flows from the database to your API and then out to the user interface. If that middle API layer goes down, your entire system goes offline immediately. Think of it like a bridge held up by one single pillar. If that pillar collapses, your data cannot get across. But what happens if you add redundancy? By adding extra pillars to support your bridge, you ensure that if one fails, your data keeps moving safely across the others. To measure this, engineers use an availability formula. It compares the mean time between failures, or how long things run smoothly, against the mean time to repair, or how quickly you can get a system back up. Reliability is also calculated by looking at the number of backups you have, labeled here as N. The more independent backups you have, the less likely you are to experience a total outage. Ultimately, you must add backups to stop total collapse.
Why does your whole application crash when one part fails? Imagine you are running an online store where a checkout service communicates with a payment gateway. When that payment service goes down, a cascading failure occurs. The error spreads back, dragging your entire checkout system down with it. You need a better way to organize these connections, using a fuse box, which keeps services isolated. Graceful degradation is the strategy of keeping essential parts running even when others fail. Notice how we disconnect only the broken payment service, while checkout and inventory remain online. To manage this safely, you calculate a timeout threshold, which accounts for the latency buffer and network jitter. A circuit breaker acts as a safety switch that snaps shut when a service takes too long to respond, preventing the error from spreading. Think of this failure state as the current state minus the broken functionality. By isolating the problem, you allow your checkout and inventory to keep working, effectively bypassing the failed payment component so your customers can keep shopping.
What if your app could fix itself while you slept? Imagine your user dashboard, where a request flows through the system perfectly. But what if things go wrong? When a server crashes, you cannot be there to manually patch it yourself. Instead, your infrastructure needs self-healing. Think of this like a mesh where one piece breaks and the neighboring parts automatically replicate to fill the gap. To manage this, you use health checks, which are quick probes that run far more often than your recovery time objective, or RTO, which is the maximum time you can afford for the system to be down. As traffic grows, your load metric climbs toward a capacity limit, triggering the creation of a new instance automatically. When a node fails, your system detects the error and instantly reroutes traffic to a healthy, ready node. Finally, you get to maintain a steady state with an active shield protecting your dashboard around the clock.